Chapter 6, Trigonometric Functions. We are going to look at defining three new functions. One is called secant, cosecant, and cotangent. In short, we call it sec for secant, cosec for cosecant, and cot for cotangent. So these functions are simply the reciprocals of the three main trigonometric functions that you are familiar with. So sec x is defined as 1 over cos x. Cosec x is defined as 1 over sine x. And cot x is 1 over tan x. However, with the cot x, you need to have two definitions. Tan x, as you know from before, is sine x over cos x. So if you put 1 over sine x over cos x, you are flipping it. You end up with cos x over sine x. So you need to have two definitions of cot x. So the first section is just to get you familiar with how to find sec and cosec and cot of different angles. So in the first example, we've got to evaluate sec 280. So let me just write it here. Sec 280 degrees. There is no key on the calculator that is goes with sec, so you need to use the definition of sec, which is cos 280. Now, if you're thinking you're not going to remember which one is which, some people go by the third letter. So sec finishes with c, so it's over cos. Cosec it has got the third letter as s, so it's 1 over sine. And cot, it's just easy, but you could see that the third letter is t, so it's 1 over tan. Okay, then you reach for the calculator and you put 1 over cos 280, you type it in, and the answer is going to be 5.7623 significant figures. Make sure the calculator is in degrees. For cot, you can do the same, so you do 1 over tan 115, pop it into the calculator as it appears, and the answer is going to be minus 0.46623 significant figures. Okay, now in example 2, we've been asked to find exact values of sec 210 and cosec 3 pi over 4. So in order to do that, let's use the definition for sec, which is 1 over cos 210 degrees. Now, the way to find the exact values, it clearly has to have something to do with the acute angles of either 30, 45, or 60, because these are the angles that generate exact values apart from multiples of 90. So cos 210, I can rewrite it as, so 210. I can actually show you on the graph of cos function. So there is my cos. Okay, so this is 90, this is 180, this is 270 and 360. So you could see that 210 is over here. Okay, so 210 is 30 degrees away from that, from 180. So it's going to be, if you look at this very carefully, flipping it over, it's going to give me the same answer as the opposite of cos 30 degrees. So just to show you with colors, This here is 30 degrees to 180, so you're talking about 30-degree angle that you need to be looking at, but because it's below the x-axis, it gives you minus answer. So this is minus root 3 over 2. So what I'm going to do, just for so it's everything is shown, that's minus cos 30, and that gives me plus cos minus root 3 over 2, which is minus 2 over root 3. Okay, and last one here, so this is in radians. We need to be in radians for this one. Well, if you were to check on the calculator, but the idea is that you are not doing it using a calculator. So cosec is 1 over sine 3 pi over 4. So let's draw a sine graph. Let me actually do it on a different side so you could see it. So if I draw the sine graph, so where is 3 pi over 4? So this is pi, this is 2 pi. So 3 pi over 4 is over here. This is going to be the same as an acute angle of pi over 4, which is 45 degrees. So sine 3 pi over 4 is the same as sine pi over 4, which is root 2 over 2. So my cosec 3 pi over 4 is 1 over sine 3 pi over 4, and that is 1 over root 2 over 2 flipped, which is 2 over root 2. This one actually I will change into rationalize the denominator of that, because it's a nice answer of root 2. Okay, so this takes us to exercise 6a. Have a go at familiarizing yourself with how evaluation of different expressions involving the 3 new functions.